Lesson 7 is going to look at symmetry in the coordinate plane. A reflection is when an original point has an image that is the same distance from the line of reflection as the original point, but it is on the opposite side of the line. So we're going to look at some examples so we can kind of understand this a little bit better. It says reflect the given point over each of the given lines of reflection. So again, the lines of reflection is what we are reflecting over. So if we look, the given point here is -2, 3. So what I'm going to do is I'm going to start by plotting -2, 3 on my coordinate plane. So remember, we start at the origin. We would move over to -2 first, up to +3. So here is our point. It's asking us first to take that given point and reflect it across the x-axis. So here is my x-axis, and what it means to reflect over it, as it said in the definition, was that it should be on the opposite side of the line of reflection, the same distance away. So if we look, point S from the x-axis is 1, 2, 3 spots away, or units away. So what we want to do to reflect it is make point S's reflection on the other side of the x-axis on the same line here, 3 units away. So 1, 2, 3. To show a reflected point, you put this little 1 next to it. It just basically is saying this is the reflection. So the reflected point, if we start at our origin and we go over until we're directly above the point, the x-coordinate is -2. The y-coordinate is -3. If we look at the difference between these two, our original and the reflected point, we can see the first number, or our x-coordinate, stayed the same. If we look at the second coordinate, or y-coordinate, we had a 3 here and a -3 here. 3 and -3 are opposites. So what I can say is when reflecting over the x-axis, the x-coordinate stays the same, and the y-coordinate becomes its opposite. I'm going to erase the reflected point because we are now going to reflect the same point we were originally given. This time we're going to reflect it across the y-axis. So here's my y-axis. I'm going to reflect across it, meaning on the same line across, same distance. So this is 1, 2, 1, 2. So our point would go right here. That's our reflected S. So we would go over to +2, up to +3. So our x-coordinate is +2. Our y-coordinate is +3. If we compare to the original point, the -2, +3, looking at the x-coordinate, we had -2, now we have +2. So the x-coordinate becomes its opposite. The y-coordinate, however, stayed the same, 3, 3. So we can say when we're reflecting across the y-axis, the x becomes its opposite, the y stays the same. So whatever we're reflecting over, that's the coordinate that stays the same, and the other one becomes its opposite. Again, I'm going to erase my reflected point. Now what I'm going to do is a bit of a double reflection. So what this is saying is it wants me to take the -2, 3 and reflect it first across the x-axis and then across the y-axis. So if I reflect it across the x, remember we started here, 1, 2, 3 away. 1, 2, 3, it would go here. But then it wants me to take this point and reflect it across the y-axis. So it would be 1, 2, 1, 2, and it would wind up right here. This new point is positive 2, negative 3. So when we reflect across the x first and then the y-axis, our x-coordinate becomes its opposite. Positive 2 is the opposite of negative 2. And 3 becomes negative 3, so the y also becomes its opposite. So they both become opposites when we do that, reflect across the x and then across the y. The last one wants us to reflect first across the y-axis and then across the x. So now we're going to go this way first. So this is 2 units away from y, so 2 units away from y here puts us there. And then to reflect across the x, this is 1, 2, 3 away from the x, so another 1, 2, 3 puts us right here. Notice this is also at 2, negative 3. Same point. So the x became its opposite, the y became its opposite. Okay, so it doesn't matter if we're taking a point and reflecting first across the x and then across the y, or first across the y and then across the x, we're still going to end up with the same thing. This is actually the same thing, or what we call reflecting across the origin. And if you look, here's my origin. Here's this point, here's this point. They are, my lines aren't really pretty, but they are exactly the same distance from the origin, so that same idea. So if you reflect across one axis and then across the other, it's the same thing as reflecting across the origin. And this is how you're going to see it written. And again, the x-coordinate and the y-coordinate both become opposites. So let's look at some more. We're going to practice just a little bit more here. So if I have an original point of negative 2, 4, and I'm reflecting across the x-axis, I'm actually going to use the graph as my check. So remember, x-axis means x is the same. So whichever axis you're going to reflect over, that's the coordinate that stays the same. So my x-coordinate will stay. That means my y will become its opposite. So remember, x is first, y is second. So x stays the same, so negative 2 stays negative 2. Y becomes its opposite. Opposite of positive 4 is negative 4. So let's check it. Negative 2, positive 4 is here. If I'm reflecting across the x-axis, that's 1, 2, 3, 4 units. Sorry, that's a little bubbly. 4 units away, so that means 1, 2, 3, 4 units away puts my point here, which is negative 2, negative 4, just as I have here. So I don't even need the coordinate plane to do these types of problems. Now I'm going to reflect across the y-axis. Remember, whichever axis you're reflecting across, that's the one that's going to stay the same. So my y-coordinate will stay the same this time, and my x will become the opposite. We're always going back to this original point that we started with, not the point right before it, so this one. So the x is going to become its opposite, so the opposite of negative 2 is positive 2, and the y will stay the same. So the positive 4 will stay a positive 4. Again, to check, this was our original point. It's 1, 2 away from the y-axis, so 1, 2 on the other side becomes 2, 4, 2, 4. Now, as we noticed from the first page, the results of these two things gave us the same. So we're just going to do it once. Again, this is called reflecting over the origin. And remember, when we reflect over the origin, both the x become its opposite and the y become its opposite. So back to the original point, the opposite of negative 2 is positive 2. The opposite of positive 4 is negative 4. So I would go over to 2, down to negative 4. And again, if this is my origin, these look like they're the same distance from that origin. So that's how you reflect. You just have to remember those simple steps. If you're reflecting over the x stays the same. The y becomes its opposite. If you're reflecting over the y then stays the same. The x becomes its opposite. And if you're reflecting over the origin, they both become their opposites.